Hey guys, it's Kimberly again. Thanks for tuning in for the second part of this lecture. If you remember, the first part of this lecture focused on CAD, computer-aided design, and how that fits into the real world. So we gave you a homework assignment and we received a ton of submissions to replace the design in the first lecture, the state of Mississippi, with a conceptual design submitted by you. So we put all of the submissions into a hat and drew one, and we came up with the Whippet. It's the Kosciuszko school mascot. So we were really excited about that. I sent that drawing to Lincoln, so you're going to see a video following this for Lincoln putting that into SolidWorks and getting the CAD file. And then he sends that to David, and David's going to show you an overview of 3D printing, the printing machine, and then some clips of it actually being printed and the final design. So we're really excited about that. Thank you to David for helping us out, and thanks to Lincoln for being a wizard in SolidWorks. Okay, hope you enjoy it.
Hey guys, how's it going? So, you might actually hear some animals in the background running around, so I hope that doesn't distract y'all. What we're going to do is actually, y'all sent us some sketches of things that y'all would maybe want to see replace this Mississippi right here. And we selected one, and it was actually y'all's school logo. So I actually thought that was really cool. So we're going to start a sketch on here to get rid of this Mississippi. Now there are many other ways that you can do this, but this is just going to be kind of a good example of what you can kind of do with extrusions. So we're just going to create a rectangle right here. And what my goal is to extrude this rectangle at the same depth as this the clip, and it's going to just kind of fill in the hole. So we're going to hit exit sketch here. We're going to go to extrude boss base, and I'm going to say I want it to extrude from here to here. You notice that it fills in that Mississippi, and as long as we have merge result clicked or selected, it will not put any lines around here. So just to give an example, I'll uncheck merge results, and now it's its own separate thing. So I can click on just that, and you can still see the Mississippi in there. But if I come back here and I edit, and I say merge results, then there's nothing there. It's one solid body. So what we're going to do is we want to insert this dog. So let's go ahead and start a sketch on this face, and we want to import the dog. So let's go to Tools, let's go to Sketch Tools, and you'll remember Sketch Picture, and we're going to pull in dog.jpg. And it's a rather big picture, so it took a second. And we're going to shrink it down so that it'll be at least similar size to what we're looking at. And we want to turn it by 90 degrees. And we're going to place it about in between. Now, you can do transparency, which I haven't messed around with a ton, but we're just going to kind of do this. Oh, there we go. So this is making the image transparent. So 0.7. So now we can see the dog, but we can also see what's behind it. We're going to use this to kind of size up the dog. Okay, so we've got the dog kind of about in the center. It looks pretty good, about the same distance from the nose it is from the back of the foot. We might make it a little more, a little bit easier to see. So let's actually, since we've already got it placed, as a matter of fact, we can just put it back down to 0 and just use the paper now and draw over it. So what we're going to do is say OK, and now we need to start drawing the dog out. So I'll just go ahead, we'll do this 3-point arc, and we'll put one from here to there, maybe one from here to here, then maybe a little straight one down here. It's looking like we can use some straight lines on a few of these. So let's keep doing that. So go from here to maybe here, from here to here, and then maybe it's looking like we're going from here to here. And remember, this is going to be a cutout, so a lot of the detail in the center we're not going to be able to get. So this eye right here, we're not going to be able to put that in, but we'll be able to put the entire outline into it. So let's go ahead and continue putting in these. We're going to put in the belly, or the, actually this would be where more the breastbone would be. And we can just get away with a line right here is what it looks like. And we're going to come around here. Looks like we got the bottom of that going pretty well. And come here. And so basically all we're doing is we're just using the line tool and the 3-point arc tool to make this entire thing. It's actually rather simple. So something you've probably noticed already is that the 3-point arc tool, what it does is it just simply creates an arc based on 3 points. So you click the starting point, you click the end point, and then you click the one of the points that would be kind of along the trail of it. So I'll just give an example here. So here's the start point, here's the end point, and now I'm selecting where the next point will go. So we're going to put it right here. So 3 points, 3-point arc. I'm going to put a line here, and then another line to here. I'm going to go here. Actually, that kind of makes me feel like that should be an arc as well. So we're going to go from here to here. Here. Oh, little mistake on that one. So from here to here. And then we'll go from here to here, around it, and then we're going to use a straight line to go back up here. We're going to go back to our 3-point arc. So all of this in SolidWorks is this is very straightforward, and this is actually a fun thing to kind of sketch around. But you'll notice that I'm not doing exactly that what each thing is. You'll notice this line's a little bit off, and that's fine. You're just kind of getting as close as you can get with these simple tools that you have, but you can make some pretty complicated things with it, which is exciting. So we're going to go here. I'm going to use a straight line again here. Here, and I know y'all love watching me draw lines, but we're almost done. So just a few more seconds and we'll have this dog drawn. Gonna kind of round that face off there, and then we'll kind of put it up like that. We got ourselves a little nose here. We'll do that with a circle tool. So let's go here to here. Gonna use another one here. And then we'll use another one here. Okay. Oh, we got to get this leg. We missed out on one piece. Let's go ahead and do that. So here to here. There to there. Let's just put ourselves a line here. Do a line here. There. And then it looks like we're just kind of coming around to here. And then we're doing a line straight up to there. So, yeah, thank you to the student who made this one. And it was a really good idea to do the mascot. I like it. We're gonna do a little circle right there for the nose. And here's the dog. This is him. If we were to take away this, actually we need to kind of cut off some things just to make it all a closed surface, or a closed sketch. So we can't have openings and these coming out here. It's not necessarily that they're gonna cause an issue, but they could. So we're gonna go ahead and put these down here. And that, once we remove this piece, so we're gonna add in a little piece right here to replace that side, and we'll add in another piece to replace what's here, and then we're just going to delete each one of these. So now those are closed, and we're going to go ahead and exit the sketch. We're going to take away this image. So there's the dog. So if we cut this out, let's go ahead and go to Features, Extruded Cut, and we're going to select our sketch. It's going to take a second to load, and we want the whole thing cut out of it. So if we do that, we're going to say we want it through all. And hit go. And there's the dog. So it's very simple, but there's a lot of very complicated things that you can do. And I just think that looks really cool. So I'll actually show the one that I made earlier, kind of based on the school logo that I pulled online, and I think that's the one that we're going to be going with, because it's the official one that y'all can all see and recognize, and I think that y'all's school will be really happy about it. So let's go to Open, and let's go to our dog. And so, no, we don't want to do feature recognition. And so this is the dog cutout. And this was taken from just one of the images that y'all had online. So I hope y'all like it, and I hope y'all learned a lot, and just enjoy the rest of your week. Bye.
Hi everyone, my name is David Hauser, and I'm the owner of Hauser Drafting and Design. I'm a freelance mechanical engineer from Pennsylvania. I studied mechanical engineering at Penn State University. Not too long ago, I was in you guys' position in high school, learning about the STEM field and seeing kind of what sparked my interest, and that was mechanical engineering for me. It was the best decision I ever made, and I learned some incredible things in college, and I'm excited to showcase some of those things I learned with you guys today pertaining to 3D printing. So I've been told that you guys have been working with SolidWorks and learning the interface and creating some files, and I'm actually told that this file is one that you guys produced. We have the dog icon here in the center, and this is one of the mask connectors to help some of our healthcare heroes right now with what's going on in the world. So I'm just going to walk you guys through basically from start to finish, from me receiving this file to us loading it in the 3D printer and to having a tangible product at the end of the process. So as I said, I received this file via email. It is the STL file that you guys created. This is just it's called a Print 3D. If you can see in the top left where my cursor is, it's just a program automatically loaded into my Microsoft computer that allows me to see these 3D parts. But I have obviously other softwares that we'll use. So just to show you that this is how I see it originally, and then what I did was I saved that to my files. As I said, it's an STL file. So then what we're going to open up is it's a slicer software. This particular one is Creality. I use Creality brand 3D printers. So this is a software that comes with those printers. It's automatically loaded in the memory card that I received, and I'll show you how we'll use that memory card to save our STL file to, and then load it into our 3D printer. In this particular case, we'll load an STL file, and then this slicer will convert it to a file type called G-code. That is how my particular printer recognizes different settings and things like that we can manipulate in this slicer software. So I'll go ahead and load that up here and show you guys. So it's just file load, and it's saved as it's just standard dog STL, and we're going to open that up. So then what that does there is it shows us on the printer bed, and we can manipulate that in any direction. We can drag this around, put it in any part on the printer, or what we can even multiply them. Say we wanted to make 2 more, so now we're making 3 of them total. So you can really position these on the bed any way you would like. You can use some of these to rotate them in different fashions. You can see that center one's rotating around. For these particular one, print orientation, just the bottom completely down flat. Certain parts for strength, print orientation is very key, but obviously these parts aren't quite as, that's not quite as a necessity for this particular part, but depending on where you're going to be experience stresses, if you have any stress concentrations or anything like that with your part, each one's individually assessed at the time, and that'll be kind of something you guys will learn from intuition. But just kind of wanted to cover that to bring that to you guys' attention. So we're only going to print one of those here for this application. So we'll get that ready. And as you can see in the top left, I'll bring you guys a little closer here. It shows us an estimated print time and then how much material it will take. So it's estimating this will take 24 minutes and be 5 grams worth of material. So as I said, we have some more advanced settings. That's what I'm currently loaded in right here now. For example, the most important one that I'll just cover real quick is our layer height. So in the top left part of the screen here, you can see layer height is 0.2, and that's in millimeters. So the layer height is how high our extruder and our 3D printer will go up in the direction of the Z-axis each time a layer of printer filament is laid onto the part itself. So right now we have it set at 0.2 millimeters. So the extruder will go up in the Z-axis away from the bed in an increment of 0.2 millimeters per layer that it prints. As I'm sure you guys are familiar, if those of you that aren't, the printer will lay the material in layer by layer segments. And there'll be a video at the end of this lecture to show you guys that in real time and also a time lapse. But what it is with the layer height, the lower that number, so say we would want to take it down to 0 to 0.1 millimeters. So that's a 0.1 millimeter layer height. And now what that's done is it's taken our print time from 24 minutes all the way up to 37 minutes. So the tighter your layers are, the higher the resolution the end part will be. So it'll be a more cohesive looking part because our layers are so much closer together. But just want to cover that to show you guys kind of the cool things you can do with adjusting different parameters. But we're going to go with a 0.2 millimeter layer height. That's very standard across 3D prints. If you guys get into doing these yourselves, 0.2 millimeter resolution is super high, and the higher resolution is really for if you have a lot of dimensions or if you just want a super high tolerance part. But now that we have that load on our bed, normally just try to center it up the best we can. All we're going to do is we're going to do file save, and in the side of my laptop here, you'll see that I have an SD card reader. And in there I have a small micro SD card, and that is what we will load this file onto to then put into our printer in order for it to print the part. So we just show you that. We have that loaded inside here. So we're just going to do a file save, and we'll save G-code, and then we're going to removable disk, and then we'll just kind of keep with the same naming reference of dog, save. And now we are told that that's saved. In the bottom here, it throws a message. So we'll just eject our SD card. And now we are ready to take this and we will load that into our printer, and I will show you that here in one moment. But in the meantime, I'll just run through a few other things here just to kind of some curiosity factors. So this is just our 3D printer filament. It's just like a plastic cylindrical shape it comes in a spool. Normally this is a 1 kilogram spool, so 1,000 grams. Various colors. We have maroon loaded in the printer now is what we'll be printing this part with. And on the bottom here, what this is actually, it's a carbon fiber PLA blend. So there's really endless possibilities for what is out there for different filament types and different blends that there are in now. The technology is really just getting out of this world with what's available. So I just kind of wanted to show you guys that because it's something that just really interests me, and I'm so curious about all these different filament types and materials that they're blending in now. This particular filament is a 70-30 blend, so 70% of it is PLA and the other 30% is carbon fiber. So something super cool to keep in mind learning about 3D printing is that different parts there may be benefits with different types of filament. So different compositions and additives added to the PLA that could really help with certain situations if the part will be experiencing a lot of heat or a lot of stress, or it's really just dependent upon the part, and that's just an evaluation that you can make at that time. But I just want to put that out there for you guys to keep that in mind as you kind of enter into the world of 3D printing and start to learn. And I hope this video really interests you guys and maybe will draw you towards learning some more about it. So now we'll go ahead and fire up our 3D printer. While this is booting up, I'll just go over a few of the features of this particular printer. I mentioned a few different parts of terminology in the previous parts of the video, so I just wanted to show you guys what I was referring to. So this is our printer bed. This is where our filament will be extruded onto. It'll begin with one layer and then a next layer and so on and so forth. As mentioned, it will be in 0.2 millimeter increments. So this is our extruder head that will move up this axis, which is our Z axis, in 0.2 millimeter increments. We can adjust that, but as we said before, this will be a 0.2 millimeter layer height print. This under here is our extruder head, so that is where the filament will actually come out of, and as you can see, it really necks down towards the end there. Actually, the cross-sectional diameter of that is 0.4 millimeters. It's pretty standard across printing PLA, and other materials will require different extruder head diameters, or some filament can come in larger sizes. This begins as 1.75 millimeter filament. Then when it's heated up, it extrudes at a 0.4 millimeter diameter under our bed. So we have our micro SD card here. What we're going to do is we're just going to take that, and then this is our slot where our SD card inserts. This is if you're putting one in your laptop or a camera or something like that. So now we have our card inserted, and on our screen here I'll just show you what we'll be looking for in our target temperatures. So this is our extruder, and then this is our bed temperature. So currently those are each set at 0, and these are the temperatures that will correlate to what we're trying to achieve. Our extruder, we're looking to be around 200 degrees Celsius for PLA, and for the bed it's 60 degrees Celsius. Those are preloaded into this particular printer, as I have it recognized that I'm currently printing with PLA. For example, our carbon fiber filament needs to run at like 230 degrees Celsius extruder head, so that value would be 230 target. So I'll just run through. It's very straightforward, especially once you get comfortable with them. Right now we'll just let the printer know we put our card in. So we're going to initiate that. Now we're going to go and say print from our card, and then select the G code that we had saved from the slicer. And now the printer recognizes it's time to begin printing. So you can see the bed is heating up, and this is adjusted to 60. And then once this temperature, the bed temperature actually reaches that 60 degrees Celsius, our extruder head will begin going up to 200 degrees Celsius. And then the print will initiate, as you guys will see in the next part of this video, as a time lapse, and see for yourselves the print and the file come to life. Alright everyone, so now that our print is completed, it's time to harvest it from the bed. Normally just use, sorry about the shine there from the light, but just a scraper of some sort. This is the one that came with my printer. These are pretty standard, and then all we're going to do is we're going to get underneath of the print itself as it's adhered to the bed, and then just scrape it off. Now that that's loose from the bed, we can inspect our print here. So this one turned out really nice. Something, 3D printing is not an exact science, so sometimes you will have failures if some of the filament gets caught up or something during the process, but I'm really happy with how this one turned out. And that's pretty much 3D printing from start to finish. It's very straightforward with the right technology and the right programs. It's very easy to do, and it's something that's very interesting to me, and I hope you guys feel the same way. And I hope that this lesson was interesting and you guys learned something today about 3D printing, and hopefully you guys get to apply that someday in your professional careers. Good luck with your future endeavors, and stay safe out there.
Once again, that was a really cool conceptual design submission. So cool that we thought that we would print 50 of them. We're going to send them to your instructor, Ms. Pamela Kane, who's going to then distribute them to healthcare professionals in your local area so that they can benefit from your creativity. Hope you enjoyed these lectures and have a great day.